Hi everyone, I'm just going to go through this example we had from our classwork today and clear up any ambiguity. So this problem involves using the law of cosines. So I have the version of that we're going to be using here because we're given side lengths B and C and the angle in between those sides, which is 35 degrees for A. Alright, so now we are going to plug those values in to our formula, or into the law of cosine. So we're going to substitute in 8 wherever we had B in the formula. We're going to substitute 11 wherever we have C in the formula, and we're going to substitute not A here, but we want to make that 35 degrees. Alright, and then we'll compute that and then take the square root. Alright, so to solve for A. Alright, so computing that, let's see what we end up getting. Alright, so using your calculator, computing that out, you'll end up seeing that that's 40.82924.021. Or if you write all the decimals down, now taking the square root, and keep in mind when we solve this by square roots, we're only going to consider the positive solution because we're talking about a length here. So I'll leave some of the decimals out, but include as many decimals as you can here. And then if you do that, we're going to get A is equal to 6.389. I'll just round it to 4 decimal places for now, and we'll round that off to 8. Okay, so fine, no ambiguity there whatsoever. Now, if you look at some of the other videos referenced and some of the examples we did in class, you have options from here to finish this problem out. Alright, now I'm just going to sketch the triangle a little bit, and what I mean by that is we have now all 3 sides. We have one of the angles, we have to find the remaining 2. Alright, so I'm just going to freehand sketch this for now and label what we have so far. Alright, so I'm going to say this is side length C, 35 degree angle, okay, and then we've just found this side here. Now, again, I'm just freehanding this. This was 35 degrees. I'm assuming this side length was 11, this side length was 8. This was A, we just found to be 6.3898. Alright, so across from here would be capital C, and across from this side would be angle capital B, across from side length 8. Alright, now again, it depends on which side you want to solve for next and whether you want to use the law of sines or the law of cosines. So the law of cosines for this particular problem is the better choice because it leads to no ambiguity. It's a little difficult to know, depending on which angle you go for first, whether it's the right one. Alright, now I'm going to do this to showcase the most kind of difficult way to do it. The most ambiguous, I should say. I'm going to solve for side length, or for angle C, sorry. We're going to find these 2 remaining angles. I'm going to solve for angle C by using the law of sines. Again, you could also use the law of cosines there, so we're going to say sine of the angle capital C over little c is going to equal sine of the angle we know, which is capital A, over side length little a, which we just found. Okay, so substituting those values in, we don't know sine of C. Side length C is 11. We're going to have sine of 35, and then that's divided by 6.3898. Alright, now to solve for sine of C, we need to isolate that, so we're going to multiply both sides by 11. Cancel out both 11 from on the left. Remember, you think about that as 11 over 1. So we have an 11 factor in the numerator, 11 factor in the denominator. And then we have sine of C equals this number on the right side. Now I'm actually going to compute that. You can just leave it as it is. Alright, I'm going to just compute it for our purposes here. And it comes out to 0.9874. Let's just round to the 4 decimal. Oh, I guess I'll go to 5 decimal places. 1. And I have more decimals showing on my calculator. Now to solve for C, we're going to apply the inverse sine. Alright, so one of the solutions to this equation, there's lots of solutions to that trig equation. One of them can be found with the inverse sine function, the arc sine function. And if we do that, we will get that one of our solutions or possible answers here for the angle C is 80.8 I'm just going to round it to 3 decimal places, 99 degrees. All right, that's one possible answer. And this is why the law of sines sometimes is good. You know, it's nice to apply it, but it does lead to some ambiguity. So that's one solution. All right, now remember the law. Let's go back to the unit circle here, and what we're seeing is we found one of these solutions. All right, and the solution that we found was in quadrant 1. All right, so we found an angle, 80.89. It's about right there. That's one answer. The other solution at the same height in the second quadrant, remember y is sine on the unit circle, would be 180 minus that angle. So we just found this one is 80.99. If you do 180 minus 80.899, you will get 99.101 degrees. All right, so that's the other solution. So the question is, which one is it? Okay, is it 80.899 or is it 99.101? All right, now before we go too much further, let's write down what our possibilities would be, and I'm going to write those in green for the remaining angle in our triangle. Remember, we had angle A was 35. I chose to find C first, okay, using the law of sines, and that led us to these two possibilities. Now, adding 35 and 80.899 and subtracting that from 180 would give us the remaining side would be possibly B would be 64.101 degrees, or if we took this option, we would have 180 plus 35, minus 35 minus 99.101, and that lead us to the other possibility of 45.899. Now that's just a little bit uncomforting here, and we gotta know which one is right. All right, so is it the pair where we have 80.899 and 64.101, or is it option 2, right, where we have 99.101 degrees and the corresponding angle B being 45.899? It turns out it's going to be the second one, and it's not super obvious why in this case, especially when you're freehand drawing stuff like we did up above here. All right, and unlike an example that I'm going to reference in the textbook in a minute, it's not, the numbers are, the angles in that are close enough that it's a little hard to reason it out just by looking at the angles themselves, but it is doable. I'm going to give you a couple options for how and why this should make sense. I'm going to redraw that angle or that triangle that I had drawn up above a second ago. So that's 8 units, that's like 11 units, and here's our other one. All right, now I maybe exaggerated that a little bit too much. All right, so it's a little tricky, all right, to see this, but let's say this is 35 degrees. Across from that we had 6.3898. That's what we found for side little a. This was side length 11. This was side length 8. All right, now one way to reason it out, and then I'm going to show you a picture, which is maybe a better way to look at this, is to say to yourself, well, across from a 35-degree angle, we have a side length which is 6.3, let's just say 6.4, all right, for discussion here. Well, if we were going to end up with the first possibility as our answer, right, option 1, if that was correct, I'll say this is option 1, this is option 2. If that was correct, then that would say across from angle B, we would have to have this one have been 64.101 degrees. But 64 point, that's almost double 35. Double 35 is 70. If that was the correct answer, then this side length that we came up with from the law of cosines of 6.3898, that's not quite close to double the side length we have on the other side, which is side length 8. All right, so that doesn't seem correct either. All right, just by kind of scaling it there. Again, if it was 35 degrees is the given angle, and that's across from side 6.3898, we would expect that that the angle across from side 8 should be somewhat close to 35, because the side lengths here are close, and we're looking at the side length of 8 and then its corresponding angle. All right, so hopefully that makes decent sense. I think a better way when you're in a tight situation like this is to actually draw an accurate graph with some graph paper, and I'm going to include that now. All right, so I made plot of this triangle using Desmos. All right, and I've drawn this more to scale. I'm going to label it a little bit here. So this side length I'm assuming is 8. You can hopefully see on the x-axis that this side length is 11. I cooked this up, so this is 35 degrees. Now, I think it's pretty clear from this picture, this angle that we're talking about, which is angle C in the figure, that's got to be close to or greater than 90 degrees, right? That, looking at that, it's over a right angle, it's over 90 degrees. So that would put us more in the second camp as far as our possibilities. Okay, so that's really the better way to reason it out for this particular problem. All right, so, and that was kind of unintentional. I didn't intend it for it to get that sticky. All right, in terms of the cases, but it turns out that this is the winning pair, where we have 99.101 and B is 45.89. And again, you can kind of reason it out just from the size of the angles. Side length 8 and side length 6.38 are close to each other, so those, in terms of their lengths, those angles shouldn't be that far apart. So 45 and 35 aren't that far apart, versus 35 and 64 are quite further apart. All right. Now again, the other way to avoid any of this ambiguity for this kind of problem is just to use the law of cosines to find the second angle, and then you would have gotten directly either 99.101 or 45.899 immediately, no ambiguity in terms of solving with the inverse cosine. All right, I just wanted to mention one of the examples from the textbook. This is example 1 from this section of the law of cosines, and they take that approach to go through and solve. All right, so I'm just going to show some of the details here. So the first step, very similar. They have to use the law of cosines. You can read through that. They get the side length B. They choose again to use the law of sines to find out, all right, solving for angle, they're referring to that as alpha, we're calling it capital A, is 56.3. They do mention the other possibility would be 180 minus 56.3 would be 127, but if we go back to the original picture, that can't be correct, and it's very obvious why that can't be correct, because that would have to be the biggest angle in the triangle, because we already had a 30 degree. Well, we can't have the largest angle be across from any side but side C. Right, so it certainly can't be angle A, which is alpha, which is across from side length of 10. That cannot be 123 degrees, right? The largest angle has to be across or corresponding to the largest side of the triangle. So it's very cut and dry in this example which one to take, which one to reject. Was not as cut and dry in the example that we did. All right, that's it for this video.